In our previous lesson, we wrote program to insert a node at nth position or a given position in a list, in a linked list. Now in this lesson, we will write a program to delete a node at any given position in a linked list. So once again, I have drawn a linked list here. We have 4 nodes in this list at addresses 100, 200, 150 and 250 respectively. So this is my example of a linked list of integers, and let's say we number the positions on a 1 based index. So this is the first node in the list, and this is the second node, this is the third node, and this is the fourth node. When we talk about deleting a node from the linked list, we will have to do two things. First, we will have to fix the links so that the node is no more a part of the list. Let's say in this case we want to delete the node at third position. So we will go to the second node. For nth node we will have to go to the n-1th node, and we will have to set the link part of the n-1th node as the link of the nth node, which will be the n plus 1th node. So we will cut this link. And now this node at address 150 is not part of the linked list, because when we will traverse the linked list, we will go from address 100 to 200, and from 200 we will go to 250. This is one scenario for deletion in which we have a node before and a node after. There will be special cases like we may want to delete the node at the first position or the head itself. In that case we will have to point head to the second node. We will have to build this link. We will talk about all these special cases in our implementation. Let's first understand the logic. Now fixing the links is not good enough because all that we do when we fix the links is that we detach the node from the linked list so that it is no more accessible, but it is still occupying space in the memory. As we know, a node is allocated space from what we call the dynamic memory or the heap section of the memory. We have talked about this earlier. In C or C++, we have to explicitly free this memory when we are done using it because it is not automatically deallocated. And memory being a crucial resource, we do not want to consume it unnecessarily when we do not need it. So the second thing that we will have to do is we will have to free the space that's being taken by the node, and that's when the node will actually be deleted from the memory. So let us now write code for this. I'm writing my C program here. The first thing that I have done is I have defined a node which is a structure with two fields, one to store data and another to store address of the next node. So the second field is a pointer to node. Now to create a linked list, we will have to first create a pointer to node, a variable which is pointer to node, and that will store the address of the head node or the first node in the list. And now I want to define three functions. First, insert function that will take some value, some data to be inserted into the list, and always insert this value at the end of the list. Then I want to define a print function that will print all the elements in the list. We have defined this variable head as a global variable, so it will be accessible to all these functions. And the third function that I want to write is delete, that will take the position n of the node to be deleted and delete the node at that particular position. We will go back to implementing these methods. First I'll write the main method. So in the main method, first what I'll do is I'll set head as null, so at this stage the list is empty, and then I'll make a couple of calls to insert function to insert some integers in the list. So after this fourth insert, the list will be 2, 4, 6, 5 because we are always inserting at the end of the list. This insert function will insert the node at the end of the list. Now what I want to do in my main method is I want to ask user for a position, and I'll input this position from the console, and then I'll delete the node at this particular position, and then I'll print the whole linked list. Let's also make a call to print after all the inserts. Okay, so this is what we want to do in our main method. We want to insert 4 integers in a linked list to create a list 2, 4, 6, 5 in this order. then I want to print the list, then I want to input a number from the console and delete the node at that particular position. Now let us assume that we will always give a valid position, and in my implementation also I will not handle the error condition when position will not be valid. We have seen implementation of insert and print earlier, so I will not go into their implementation details. What I'll do now is I'll implement delete function. Now in my delete function, let's first handle the case when there is a node before the node that we want to delete. So we have an n-1th node. What I'll do is I'll first create a temporary variable that is pointer to node and point this to head, and using this temporary variable we will go to n-1th node. To go to the n-1th node, we will have to run a loop n-2 times, and we will have to do something like this: temp1 is equal to temp1 dot next. Now what I'll do is I'll create a variable to point to the nth node, name this temp2, and this will be equal to temp1 dot next. And now I can fix the link. I can say that adjust the link section, the link part of n-1th node to point to n+1th node, which will be temp2 dot next. Now our link is fixed, and this variable temp2 stores the nth node reference to the nth node, so we can make a call to free function. Free function deallocates whatever memory is allocated through malloc. If we were using C++ and if we would have used new operator, we should have said delete temp2. Okay, now we should be good. This much code will work for scenarios when we have an n-1th node, and even if there is no n+1th node, if n+1th position is null, this will work for that scenario. I leave that as an exercise for you to validate. We have not handled one special case when we want to delete the head node. So if n is equal to 1, then what we want to do is we just want to set head as temp1 dot next. Temp1 is right now equal to head, and now head has moved on to point to the second node, and temp1 still points to the first node. So links are fixed, and we can free the first node, which is now detached from the linked list because head is now pointing to the second node. Okay, so this is our delete function. I have missed one thing here. For n not equal to 1, we should not execute this section of the code. So either we put an else statement after this, or what we can do is we can say return after we execute these statements for this condition. Now this code should work if I've got everything right. So let us now run this and see what happens. I have already written the insert and print functions. I'll come back to this main function. This is my list 2, 4, 6, 5, and I can enter any of the positions 1, 2, 3 or 4. So let's first say we want to delete the head node, and we are printing the list after deleting a particular node. So the list now is 4, 6, 5. This seems to be correct. Let us run this again, and this time I delete number 5 from position 4. The list is now 2, 4, 6, which is correct again. Similarly, if I enter position 2, the list is 2, 6, 5, which is correct. So we seem to be good. I'll quickly walk you through this code in the logical view to make things further clear. Let's say we first make a call to delete node from the first position. That is, we want to delete the head node. So in this code, what we are doing is we are first creating a variable temp1, which is pointer to node. Initially temp1 is equal to head, so it stores the address 100, so it points to the head node. Now n is equal to 1, so we come to this instruction, head is equal to temp1 dot next. Actually this is temp arrow dot next, but while reading we read this as temp1 dot next. This is nothing but a syntactical sugar for this statement, asterisk temp1 dot next. So we are dereferencing this pointer variable to go to this node and then accessing the next field of this node. Now we are saying head is equal to temp1 dot next, so head is now 200. So we are building this link and breaking this link, and now in the next line we say free temp1. So we want to free the memory which is being pointed to by this variable temp1. Temp1 still points to this node at address 100. So this node now will be cleared from the memory. And now we return, so this function does not execute any further. It finishes its execution. Once the function execution finishes, temp1, which was a local variable, also gets cleared from the memory. Head is a global variable, so it does not get cleared. This is how we know the linked list. This is the identity of the linked list, this particular variable head. Let's rerun this code again, and this time I want to delete the node at third position in the list. I have drawn this initial list. So once again we create this variable temp1. We say that the address here is equal to 100, so it points to the head node or the first node. And now n is not equal to 1, it is equal to 3. So we come to this particular loop. N is equal to 3, so this loop will execute exactly once. This statement will execute exactly once. So temp1 will now move to address 200. So temp1 is now pointing to the second node. This is what we wanted to do. We wanted temp1 to point to n minus 1th node. N is 3 here. Now we create another variable, another pointer to node, temp2, and we set this guy as temp1.next. temp1.next is 150, so we set this guy as 150. So this guy points to the nth node or the third node. Now in the next line we are saying that temp1.next, this value which is 150 right now, is now temp2.next, address of the n plus 1th node or fourth node. So this guy will now be 250. So we are building this link and we are breaking this link. So we have fixed the links, and now finally we are saying that free the memory which is being pointed to by temp2. So now this third node, the memory block, will be deleted from the memory. And once this function execution finishes, all the local variables temp1 and temp2 will be cleared, and this is what the list will be. This node at address 250 will now be the third node. So this was deleting a node at a particular position in the linked list. We can also have a problem where we may want to delete a node with a particular value. You can try implementing it. In the coming lessons we will see more problems on linked list. So thanks for watching.